Good morning. It's July 25th, and this is your daily brief in science. Here's everything you need to know. A recent study from researchers at UC Santa Barbara highlights the role of artificial intelligence in monitoring industrial fishing activities within marine protected areas, or MPAS, using satellite data. Published in the journal Science, this research examined 1,380 MPAS that collectively cover 2.1% of the global ocean, including notable sites like Australia's Great Barrier Reef and Hawaii's Papahanaumokuakea Marine National Monument. The findings indicate that 78.5% of these MPAS experienced no commercial fishing activity, demonstrating the effectiveness of strict fishing bans in safeguarding marine biodiversity. Specifically, strongly protected MPAS recorded, on average, 9 times fewer fishing vessels per square kilometer compared to unprotected areas, with 25% showing no fishing vessels at all from 2017 to 2021. However, challenges remain, as some areas like the Chagos Marine Reserve and the Great Barrier Reef Marine Park still encounter illegal fishing, averaging around 900 hours of activity per year. Among the MPAS where illegal fishing was detected, 82% had less than 24 hours of activity annually, indicating that while violations exist, they are often minimal. The study suggests that countries can utilize satellite tracking to bolster patrol efforts against illegal fishing, which could enhance both conservation and economic outcomes. Additionally, MPAS not only protect marine ecosystems, but also benefit the fishing industry by promoting increased fish populations in nearby waters. These findings support the Global Biodiversity Framework's goal of protecting 30% of the oceans by 2030, aimed at regenerating fish populations and deterring illegal fishing. Researchers analyzed 5 billion real-time vessel locations from the Automatic Identification System and satellite radar imaging, noting that AIS data frequently misses nearly 90% of actual fishing vessel detections. Collaboration with organizations like Global Fishing Watch could further improve ocean monitoring, especially for nations with limited resources. Future research will be necessary to ascertain whether the lack of industrial fishing in these MPAS results from effective enforcement, or if these areas are simply less frequented by industrial fishing activities. A significant development in scientific publishing has emerged with the retraction of a controversial paper from 2010, which claimed that a microorganism could utilize arsenic instead of phosphorus. This retraction follows extensive criticism regarding the methodology and findings of the study, which was initially heralded by NASA as a potential breakthrough in the search for extraterrestrial life. The decision to retract the paper comes nearly 15 years after its original announcement, reflecting evolving standards in scientific journals concerning the reliability of published research. Editor-in-Chief Holden Thorpe noted that the retraction was based on new criteria allowing for withdrawal of studies when experiments do not support key conclusions, even without evidence of fraud or misconduct. The retraction notice indicated that contamination influenced the results of the original study, undermining its conclusions. Critics had previously pointed out numerous flaws, including potential phosphate contamination in the growth medium, which could have affected the findings. Subsequent studies published in 2012 refuted the original claims, demonstrating that while the bacterium GFAJ-1 could tolerate arsenic, it did not use it as a substitute for phosphorus. This retraction has reignited discussions about the implications of the arsenic-life study, with some experts advocating for clarity to avoid inferring misconduct, while others argue that the flawed conclusions justify its removal from the scientific record. NASA officials, including Associate Administrator Nicola Fox, criticized the retraction, stating that it undermines the integrity of the scientific process and could set a concerning precedent for future retractions. NASA has encouraged Science magazine to reconsider their decision, emphasizing the importance of supporting researchers who take intellectual risks. The authors of the original study have publicly disagreed with the retraction, maintaining that their data is valid and asserting that scientific disputes are a normal part of the research process. This saga highlights the ongoing challenges of rapid scientific communication in the social media age and the complexities of peer review processes, which have evolved significantly since the original study was published. Recent advancements in long-read sequencing technologies are transforming our understanding of human genomes. A comprehensive study analyzed the genomes of 1,019 diverse individuals, revealing a vast array of structural variants that deepen our grasp of genetic diversity and disease susceptibility. Particular attention was given to the major histocompatibility complex, a crucial region for immune function where variations have been linked to vaccine responses and autoimmune diseases. The dataset captured over 139,000 structural variants, with a majority being rare, underscoring the extensive genetic variation across populations. Notably, genetic diversity was highest in African populations, with individuals showing a median of nearly 24,000 structural variants, compared to about 19,000 in other groups. Researchers achieved highly contiguous, haplotype-resolved assemblies for 130 genomes, closing 92% of gaps from prior references. The study also identified over 4,000 new variants in centromere regions, highlighting their mutability. Supported by multiple NIH grants, the research provided insights into survival motor neuron genes associated with spinal muscular atrophy, revealing potential disease risk sites. In total, the study identified over 188,000 structural variants and millions of indels and single nucleotide variants, marking a 59% increase in the structural variant call set compared to previous data. The development of a new computational framework, SAGA, improved structural variant discovery and classification accuracy. Published in Nature, this research enriches genomic resources and advances our understanding of human diversity, setting the stage for future studies in genomics and personalized medicine. A remarkable discovery in the field of early animal evolution has emerged with the reclassification of a fossil known as Paleocampa anthrax. Initially misidentified as a caterpillar, this fossil is now recognized as the first known non-marine lobopodian, highlighting a significant shift in our understanding of these ancient creatures. The reclassification was spearheaded by Richard Knecht, who identified the fossil while studying millipedes at Harvard University's Museum of Comparative Zoology. Knecht noted distinctive leg features that ruled out previous classifications, leading to this groundbreaking conclusion. Advanced imaging techniques, such as scanning electron microscopy and spectroscopy, revealed nearly 1,000 bristle-like spines on the fossil. These spines may have served as chemical defenses against predators, suggesting that Paleocampa had complex adaptations to its freshwater environment. Measuring just 4 centimeters long, Paleocampa lived in freshwater habitats, challenging the long-held belief that lobopodians were exclusively marine. This discovery is particularly significant as it predates other known lobopodians from the Burgess Shale by nearly 50 years, marking an important point in the evolutionary timeline. Paleocampa anthrax serves as a crucial link in evolution between primitive worm-like ancestors and modern arthropods, offering insights into the early diversification of life and the transition from marine to freshwater ecosystems. The reclassification also clarifies the nature of the Monceau-les-Mines fossil site in France, confirming it as a non-marine location and enhancing our understanding of ancient freshwater ecosystems. Knecht emphasized the rarity of the conditions needed to fossilize soft-bodied creatures, making discoveries like Paleocampa vital for piecing together prehistoric life. This finding raises questions about the diversity of lobopodians and the potential for uncovering more misidentified specimens in museum collections, underscoring the importance of re-examining historical specimens with modern techniques. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.